Hello students, this is the another video in the series of GATE Mathematics previous year's questions. This is question number 5 which I am going to discuss. In this question it is given like capital M is a 3 cross 3 singular matrix and suppose that 2 and 3 are the eigenvalues of this matrix M. Then the number of linearly independent eigenvectors of m cube plus 2m plus I3 is equal to. So what we can do in this question, we will try to understand the data given in the question. M is a singular matrix. It is provided M is a singular matrix. And as we know, if M is any singular matrix, then determinant of that matrix is 0. And if determinant of any matrix is 0, it means eigenvalue, at least one eigenvalue I am talking about. Eigenvalue in bracket I can write at least one eigenvalue of that particular matrix equal to 0. So here in the question it is provided 2 and 3 are already eigenvalues of matrix M. So since M is a 3 cross 3 matrix, so what will be the set of eigenvalues? 0, 2 and 3. Why 0 is the eigenvalue? Because M is a singular matrix. So now if eigenvalues of M are provided here, so what will be the eigenvalues of M cube? Those will be 0, 8 and 27. What will be the eigenvalues of twice into M? So these will be 0 and 4 and 2 3s are here 6. I mean to say 2 into 3 it is 6. And then what are the eigenvalues of identity matrix? 1, 1 and 1. So I need to take here the eigenvalues of M cube plus 2M plus I3, that is M cube plus 2M plus I3 or identity matrix of order 3. So its eigenvalues will be 1, I mean to say not 1, M cube plus 2M plus I3. So these eigenvalues will be, I can take it like this, 0 plus 0, 0 plus 0 plus 1. And then I can take it like this, 8 plus 4, 8 plus 4 plus 1. And then I can take it like this, 27 plus 6 plus 1. Or ultimately what would be the final eigenvalues here? So final eigenvalues here will be 1 and 8 plus 4, 12 plus 1, that is 13, and 27 plus 6, 33 plus 1, 34. So these are the eigenvalues of this particular matrix M cube plus 2M plus I3. Students, as you can observe here, this matrix M cube plus 2M plus I3 is having 3 distinct eigenvalues. 3 distinct eigenvalues. So what is the conclusion here? Conclusion here is like there will exist 3 linearly independent eigenvectors of the matrix matrix is this M cube plus 2M plus I3. So that was asked in the question. Then the number of linearly independent eigenvectors of this matrix is equal to 3. So 3 is the right answer here. Thank you so much students for watching this video.